Okay, so what do you have? Are they like radical? Yes, right, same index, same radicand. That's all you need, same index, same radicand. So 7 plus 2 is 9, and then rewrite that radical. So cube root of p. And then the third one, let me rewrite the cube root here to be next to the little radical right there. So again, same radicals, right? So combine the coefficient. 5 minus 3 is 2. So 2 cube root of x. Try number 4 and number 5. I'll walk around, see how you do. So right there's light radical or the same index, same radicand. For those who come late. Five people want, 5 people here. It's locked. Oh, I don't know. Fix it. My thing. Yeah. Sorry. Yeah, there's people. I was hoping like more people come to class so I can show you the demonstration. It's just easier. I don't think the people online will see me doing this later. It's kind of cool. Maybe you heard about, maybe you're not. But if you're engineering, right? You probably will. So they use this in Tesla engineering. Oh, I kind of grade your scavenger hunt. I forgot. Okay, let's see. Haya, what Haya got? What's it? Number. Are you doing number? Oh, number 4. Okay, -2 root 11b. Number 5 is 4 root of 11 CD. Is that what you guys have? Yeah. All right. Okay. All right. Same. Right. We have the same index, same radical. I mean, everything under the root is exactly the same. Now I encourage you to put the 1 here if you don't see anything, so that you don't think it's 0. So 1. Oops, sorry. Let me take off that chat. So 1 minus 5 plus 3. Minus 4, so minus 1, right? So minus 1, so square root of 11b. Is that what she got? I forgot what she got. Or you want to rewrite it just negative 11b if you want. I'll take both answer. Number 5, same index, same radicand. So add the coefficient. So I have 5 plus 8 plus 5 is 13 minus 9 is negative, so it's positive 4. So 4 root of 11 CD. Do you have any question? Do you have any question? Ask now, ask me now, because the rest is gonna be based on this. Especially for people who come late. It's okay to ask questions. I'll say it again. Yeah, Kobe.
I mean, for the most part, it's just like an addition, right?
Mm-hmm, yeah. So here, here what you missed, remember in previous class, you learned how to add like term, right? Like 5x plus 2x, stuff like that. So same thing with radical. You have to determine what are like radicals. As long as they have the same index and the same radicand. I mean, so the little thing out here, it has to be the same. And whatever under the root has to be the same. Then you add the coefficient. Mm-hmm. Yeah. Yeah, do not add the inside, just the number in front of the root. Mm-hmm.
Kind of like if they were adding like
X and yeah. No, like they kind of like this, Like they both have X. Yeah. Mm-hmm. Yeah. Maybe that's what you mean. All right, this one. Are they like term? Kobe, wait, you tell me. Do they have the same index? What kind of root they have? What kind of root?
or it's square root.
Yeah, they both have, they all square root. Do they have, all of them the 5x under the square root? So yes, they are like term, right? So now all you have to do, you add the number in front of it. Right, so 3 plus 85 is 88 minus 11 is 77. Thank you. And then you rewrite that thing. Think of it like just x, right? Square root of 5x.
You don't really have to show our work on this.
No, these are simple. On the exam, you probably have something like this, more like this. I just have to teach you how to recognize like terms. These are too simple. On the exam, more like these. I told you baby step. I'm gonna try to walk you from baby step to till how you know how to run.
Wait for that exam.
Well, you know, you know, just don't call my name in your sleep. So some people stress out to call my name in their sleep. Sometimes it's not a good thing. Now I give you a practice exam, right? And like last time, it's gonna be very much the same. Sometimes even I took out the problem from the practice exam. Okay, so simplify this one. So first, I taught you how to simplify each of individual of these, right? So let's do that. How do I know? Because I know that 72, I can take out something. Same thing with 98, right? So I gotta simplify the little one first before I actually add them or subtract them or whatever. So can somebody tell me what two number multiply give me 72? One of them is perfect square root. Yeah, thank you. At this point, you just gotta know. Again, 72 is even number divided by 2, so you got is it 36 times 2. Let's finish this guy. And then you can break it apart. Square root 36 times square root of 2. Square root of 36 is 6. And then rewrite the root 2. 998. Yeah, 2 and 49. I'll write the 49 first. Doesn't matter, but I like to put the perfect square root in front. And then you break it up again. Root 49 times root 2. Root 49 is 7 times root 2. Now, are they like term? Yes, right. Say the same radical, same index. They all square root. Same the 2 under the radical. So 6 minus 7 is -1, which is negative root 2. All of these steps up to here, you already did it in the previous section, right? I think you did it the last one. All right. Why don't you guys try number 2? It's a cube root now. again, if you stuck, there's a table. Actually, this table doesn't help you because it's square root. My bad. But yeah, try your best. Oh, it's a bit of the individual. Individual transfer. 24, I can bring it up. One of them has to be a perfect sheet, something you can pull out from the.
So.
Something that you can cube. As a cat, you do a little tree, 24, and then. Three. So how many two you have? Three. So two. So that means cube of 8 times 2. Good, very good.
Well, starting, but I'm.
Oh, okay, yeah. So if you start, do slow. You don't have to finish the whole thing when I come. Just do slow. Do the tree. You stuck the tree is your friend. So the tree for 24. Oops. Is 2, 12, and then 2, 6. Oops. And then 2, 3. So because it's cute, I need at least 3 numbers, right? So 2, 2, 2. 3 of them right there. 2. Oops. 2, 2, 2. So 2 times 2 times 2 is 8. So what is that? Cube root of 8 times 3, right? And then we know that you can break it apart. So cube root of 8 times, oh, sorry. Times cube root of 3. Well, cube root of 8 is 2. So 8 is 2 cubed. And then we write the cube root of 3. And now the 81, you do the tree again. 81, 3, 27, 3, 9, 3, 3. Again, you need at least 3, 3, right? So 1, 2, 3. So 3, right? 2, 3 times 3 is 27. So plus cube root of 27 times 3. Cube root of 27 times cube root of 3. Cube of 27 is 3. And cube root of 3 is cube root of 3. And now you have like term because they're the same index, same radicand. 2 plus 3 is 5. I'm sure I believe that everybody can do this. Just take your time. You guys go stay home, take your time, do a little tree thing, and you'll be fine. All right, 3 is fraction, but don't let it deter you. You can add fraction, right? If you don't use your computer calculator, I'm not gonna make you show how you add it or subtract it. But the important thing is be able to simplify the root. So for root 80 of 80, so I need to do a little tree. Let's see. Let let me do this so I. All right. Okay. So 80. If you're good with to calculate it in your head, good for you. So people not do the trees. So 240. What else? 220. Oh, a lot of two. 210. And then 25. How many two do I need? Four. Oh, sorry. Thank you. You need at least four, right? So here you can do 1/2 4 root of 2 times 2 times 2 times 2 times 2 is 16, right? Times 5. Or you can leave it at 2 to the 4, maybe better for you. But the reason I'm doing this because I want you to recognize 16 is 2 to the 4, right? 1/2 4 root of 16 times 4 root of 5. 4 root of 16 is 2. So 1/2 times 2, right? Because it's 1/2 times radical, time half 1/2 times radical. And then times 4 root of 5. 1/2 times 2 is 1, right? So just 4 root of 5. On the exam, please be neat about when you're writing the red index, okay? So it doesn't look like a coefficient. All right, 405. Does anyone have it yet? 581, very good. 581. So I don't have to do a little tree. If you have to do it, it's the same thing divided by 5, right? So negative 2/3. 4 root of 5 and 81. Yeah. 5 times 81 times 5. And then break it apart. 2/3. 4 root of 81 times 4 root of 5. 4 root of 81 is 3. Thank you, Devin. 3, right? So 3 times 3 times 3 times 3 is 81. So 3 over 1. And then times 4 root of 5. What is it equal? Negative 2, right? Negative 2. And then 4 root of 5. Are they like term? Yes, right? They like term, same index, same radicand. So add the coefficient. 1 minus 2 is negative 1. So negative 4 root of 5. I know it's long, but the way we do it is the same thing that we did before. If I can give you a long problem, but the same way of doing things. Did I read? I feel a little fun. I feel a little similar about number 4. Oh, number 4 same thing. Number 2. Oh, I'm so sorry. I forgot to. So hang on. Let me fix it for my future. No, fix this. All right, number 5 then. A bit more complicated. Again, we do the same thing. One thing at a time. Okay, so do you guys remember how I taught you how to simplify each of these? What do? We write two radicals. One of them is the perfect cube, right? In this case, I'm sorry, it's perfect cube. The other one is not. So 8 is outside the root, so just rewrite it 8 times. By the way, these between here times. I'm gonna have one of them is a perfect cube, the other one is not. And then one number at a time. 64. Can you give me 2 numbers that multiplies is 64? One of them is a perfect cube. Hmm? 16 and 4. Yeah, I think so. Yes, you're right. Yeah, 16. No, 4Q is no. We need something three. We need more. 64. Let's see. You use your calculator. Use your calculator. So divided by 2. See what happens. What you get, Kobe? 64 divided by 2. I got 32. Keep divided by 2. Okay, I got 32. I think so. 32 so far divided by 2. So I think it's cube root of 64 is 2 to the 5th, 2 to the 6th, right? Yeah. If you do a little tree, let's do a little tree. 64 is 232, and then 216, and then 28, and then 24. Oh, all 2. Yeah. And then 2. How many 2 here? 1, 2, 3, 4, 5, 6. So 2 to the 6, right? So 64 then. So maybe so leave it at 64. Right. Maybe I rewrite it as 2 to the 6. 2 to the 6. And then q to the 6 is 6 divided by 3. So leave it like that. So nothing over here. Over here you can put 1 times 1. Right? Nothing wrong with it. This one is kind of nice because I give you a number that you can actually take a cube root right away. Okay, so 8 times, what is cube root of 2 to the 6? Remember the boot method. Kick the little exponents over. Divide into 3. 6 divided by 3 is 2. So 2 to the 2, right? So 2 to the 2. And get rid of the radical. Once you do the boot thing, no more radical. 6 divided by 3 is 2. So cube square. 2 square is 4. Yeah. That's equal 4. So 8 times 4 is 32. Q square. Yeah, 2, yeah. 2 square. Yeah, 2 square. Which is 4, the little green underneath. What about the second one? I think you can do Q root 25, 125. You guys don't have graphing calculator, do you? Except for Devin? You have. Oh, okay. You need it because I'm gonna show you. So say you don't know what 25 is, and I don't give you the table. So what is cube root of 125? You're gonna try it out. Like, is it perfect cube? We don't know, so we're gonna try it. So on your calculator, you're gonna go to math. Oops, clear. You see the math, the 4 button down, math on the left, math right below the green one, and you see end root there, number 5. So hit either you go down with the arrow or hit number 5. So plug in your root. So I want cube root, and then 125 is 5. 5. You can use your phone for now. Oh, you don't have that thing? Maybe you don't have that thing? Yeah. Go to the number 5. So 125 first. And then use this. The extra things there.
Yeah, that's why it's missing it.
Oh, my bad. Entry again. You can insert the second insert. Anyone? Yeah, let me see.
So if you plug this in the calculator
You can plug it.
all the time, it's like some, we're working, we're doing the trees to work it out. When we can use the calculator, like the numbers.
Yeah, so you're gonna check, see, 125, to me, it might be, let me check up. It might be a cube root, right? Is that what you're asking me?
No, I'm asking like, when can we use it, like, when we plug in the calculator? just to show it.
Depend if it turn out like integer, then I don't care. But if you give me decimal, that's what I want. Yeah, you give the if you take a cube root of 625, it'll give you decimal, right? So it's not a perfect cube. All right, so what is that? Is that cube root of 5 cube, right? Times q to the 6. Cube root of 5 cube is 5. So 3 times 5 times q squared, which is 15 cube squared. 32 minus 15 is 17. Thank you, Devin. 17, or whoever before that. Do you have any question?
How would you get thing from 6 to 2?
6 to
Or the
2.
cube, like a cube to 6 power.
So the, yeah, the cube root of something to the 6th power, something squared.
Boot method, Corey.
6 squares.
Yeah, the boot method, if you forget. Yeah. It's all right, thank you for asking. Okay, so now that's adding and subtracting radical. Of course, or you only allowed to combine if they are like term, right? I wish I give you another example, but if they're not like term. In the practice exam, you see. Okay, now we multiply. So n root of a times b is the same thing as n root of a times n root of b, right? We know this already. Now we can multiply. Same thing, we can do vice versa. If I give you n root of a times n root of b, you can multiply them. Now, the multiplication is a little bit less strict than adding and subtracting. You only need them to be the same way. If you look at that equation, what they have to be the same? What has to be the same? The index, right? The radicand, you don't have to. A and B are different radicand, right? As long as if you have the same index, you can multiply. And you multiply under the root too, right? Remember, adding, subtracting, you're not allowed to. You only do the coefficient outside, and whatever under the root, you keep it the same. But for multiplication, a bit more flexible. So let's do this. So square root of 11 times 8. Now, 11 is under the radical, but 8 is not. So this is the same thing as 8 times the square root of 11, right? You cannot put the 8 inside the root. If you want to, you have to square it. Because what number when you square root, you give you 8? 8 times 8 is 64, right? But you don't want to do that, right? If a number and a root, just multiply them, leave them alone. So square root of 11, I'll do slowly. So square root of 11 times 4 square root of 11. We write this. Can I bring the 4 in the front? Is that okay? If A, don't write this down. A times B times C is the same thing as B times A times C, right? I can rearrange them. Okay, okay, so square root 11 times square root 11 is square root 11 square, right? Remember, I can bring them under the root. So square root 11 times, so then maybe I'll do slow like this, which is 4 times square root 11 times 11, which is 4 times square root 11 square. I'll do it slow like that.
Because it's the square root of 11 times whatever's in that little bracket, not the bracket, but the parentheses. So that's what, I missed it too at first. I'm like, I was like, what is? Does that make sense now or not?
Yeah, no, it does. 'Cause
Yeah.
how the
Mhm,
fingers-
yeah.
Yeah.
Yeah, alright. Maybe, maybe I write the little rule.
Yeah.
Mhm. Yeah. Okay. But thank you for asking. Please ask. I don't want you to get frustrated because if I move on, it's gonna get harder and harder. And you in math, you broke something in the middle. It's very difficult to concentrate further. And all right. So, what does square root of 11 square? 11, right? So 4 times 11, which is 44. And bring that thing down. Bring bring this one down, which is 8. So square root of times square root of 11 and then plus, right? Can I combine like term? Are they like term? Are the two things like term? No, they're different thing, right? The first one has root 11, the second one is not. So just leave it alone. You're done. If you cannot combine, you're done. That's your final answer. Equal, equal, equal. Let's try number 3 first. Number 2 a little bit more difficult. Let's try number 3 first. Actually, I'll try number 2 and you guys try number 3. And then we'll take a little break. Let me do number 2 for you. And then you do number 3. Okay, same thing. It's just cute. I know it looks busy, but it's the same thing. So I'm gonna do one step at a time. So equal. I'm gonna distribute that. Right. On the exam, you give me this step, you got 1 point, even you didn't do anything next. So cube root of 3 times cube root of 9 plus cube root of 3 times 8 cube root of 18. Make sure you write the index small. Right. You make this guy smaller. Still big. Small. Okay. Now remember the rule. What they have the same index. Can I multiply the 3 and the 9? Yes, right. Remember the rule right here. This is the one in black. So root a times root b, same thing. Root a times b. So root 3 of 3 times 9. Let me finish this one. What 3 times 9 equal? 27. What is cube root of 27? If you doubt yourself, use your calculator. I'll show you how to do it already. 3, right? 3. So we've done the first term. Now the second term. Now I'm gonna, because the 8 is not under the root, I'm gonna move it to the front. Time cube root of 3 and cube root of 18, the same index. I'm allowed to multiply them. So gonna be 3 times 18 under the cube root. 3 times 18 is, what's 3 times 18? 3 times 8 is 4, 64, 6, huh? Oh, 54, 54. Okay, 54, okay. All right, so let's see, let's do a little tree thing. 54. 2, 5 divided by 2 is 2, 14, 27. Okay, so I have 27 times 2. 8 times cube root of 27 times 2. And then you can break it apart. So 8 times cube root of 27 times cube root of 2. Again, cube root of 27, you know that's 3. And cube root of 2 is cube root of 2. 8 times 3 is 24. Cube root of 2. Then you bring this down. So 3 plus, can I combine? No, can I combine 3 with the 24? No, they're not like term, right? If hypothetically, if I have something like this, then yes, I can, but I don't have that, so leave it alone. You're done. Kobe, you feel a little bit okay now? I mean, it's a lot to take, but at least you feel the flow of the work. Okay, all right. All right, you guys try number 3. I'll walk around, see how you do. After that, we're gonna do a little demonstration. Thank you, Haya. For in the meantime, I'm gonna take a okay. Look at that, you're running. You see it running, that little line running. So what I want you to do, you have your mobile strip. If you have a pen or pencil, put a letter A at one end and letter B at the other end, like on both sides. The strip-
both sides.
Yeah, just to put, see how I have A here on one side and B on the other side. So just put, so here A on, put A on both sides, you put B on both sides. Then you get the little. All right, you got it? Okay. I want you, we're gonna make a mobile strip. Flip one end and attach to the other end. Flip it first. Just one, keep one still and turn the other one. So here I have, if you do like this, you have a cylinder, right? So if you turn it, attach it. Now you get a mobile strip. I'm gonna clip mine because I need to do something later. I encourage you to do the same. I'll give you my little stapler. Here, you got it. Just pass it to people. Cool, nothing worked here. Yes. You got it? We're gonna trace. Yeah, I want you to trace. So pick a side, just trace. So put a little star here. Well, you have letter already, so you don't have to. But I don't have a letter, so I'm gonna put a star here. And I'm gonna trace. So use your pencil, pen, whatnot. Just trace along that side. Trace along that side. I'm gonna trace it.
On the outside or inside?
Outside. So start with outside. Easier for you. It doesn't matter actually.
You gotta find it, doesn't matter.
Because it's one side. There you go. I gotta find a better pen. I'm gonna trace. Make sure you always on the same side. Okay, do not change your side. Just trace along the paper. Tracing, you're gonna get a little bit of while, but just like Tony, stop trading with the finger in there. What you got? What happened?
One side.
Yeah, what do you, oh, I start at the start here, right? When I trace it, I go back to the same place. So that means the mobile strip is actually have one side. I see how Tony's track, he's tracing it, is that little highlight in there. I don't understand how the quantum mechanics, but the cool thing about moving strip is one side, right? It's one side. Now, one more cool thing is that if I have a cylinder, if I cut this cylinder in half, I have another 2 cylinders, right? Just short cylinder. But what if I cut the moving strip? Here, I can cut it and see what happens. Cut along that line, I trace. What do you think happened? Huh? Give me a guess.
Two Mobius strips.
Okay, 2 moving strips. What do you think?
I don't remember exactly, but I want to say one of them, like I know it's gonna like separate, they're not gonna be separate, I know that.
Good. They're not gonna be separate. Good. You can have another movie strip. Is that cool? I think it's cool. The other day I was talking to one of the students and he said that he's an engineering. They was doing some kind of testing for Shanghai Tesla new quarter. And one of the Tesla part, he say is because the Mobius strip is only one side, it's cheaper to do the one side for the motor part instead of 2 sides. I don't understand the mechanic, but that's what he said. So I said, oh my God, that is cool. That is so cool. So you tell me math is not applicable, right?
So, you know, you can cut it like, if you cut it twice, you can make a circle, or like it's literally like one line, it's like, I don't know how to describe it, but it's basically like one circle will be on the outside of the strip.
One more time, cut it
So,
one more
like,
time.
If you cut 2 lines down it, instead of just 1 line down it, then it'll be like one is gonna be wrapped around the other one.
Oh, it's kind of like this.
Yeah.
Oh, okay. I gotta try. Well, my clip thing is not good, but yeah, cool. Another mobile strip, like connect to another mobile strip.
I don't know if it'll be a Mobi, I'm pretty sure they'll both be.
Yeah,
Mobi
because only
strips,
one
but
side. Can't
yeah.
have a cylinder.
Yeah.
Yeah. So it's pretty cool. There's some joke about it too. Mobius. I think chicken joke or something. And then this one.
So
What is it? Chicken. Let me put this away. Yeah, why the chicken cross the movie strip to get to the same side. So here, right here, the red is trying to get to another side. So you keep going in circle, right? Not circle, but same side. Okay, all right. So that's Mobius strip. I hope it interests you, especially people who go for engineering. You know, at least one application of that. How do I, where my thing? Oh, there you go. Back to math. 2 more problems, we'll be done. I think 2 more. All right, now instead of distribute, you have a binomial times a binomial. So what do we use when we have 2 binomial multiply each other? What that term thing called? FOIL, right? FOIL. So same thing, FOIL. FOIL. So for that, 8 times 3 is. I'm gonna do it slow. 8 times 3. I literally gonna do it slow. And then 8 times root 2 plus 8 times root 2. And then the inner negative root 2 times 3 minus negative root 2 times 3. And then minus root 2 times root 2. So far, so good. Just FOIL. 8 times 3 is 24. 8 times root 2 is, can I multiply the 8 into 2 or no? No, I recommend you not, right? It is possible, but you have to turn the 8 into 4, right? So 8, so leave it like that. And then root 2 times 3 is, I'm gonna move the 3 to the front. I like my coefficient to the front. And then root 2 times root 2 is, what root 2 times root 2 equal? Root 4, which is 2, right? So 2, so minus 2. Combine like term. What are the like term? Yeah, 24 negative 2. What else? This and this, right? So 24 minus 2 is 22. Somebody combine the yellow ones for me. Thank you. Plus 5 root 2. And then you're done. Expect one like this on exam too. And it's easy. I don't think it's difficult. Just be careful. You don't even have to show me the first step. But if you be more, the more careful you are, the less likely to make mistakes. Number 5. You gotta try that. I'll give you a head start. You try that. To my note for the remark. Instructor lecture note 8.4. Okay. Can someone tell me what is unique about this problem? I'll show you 2 ways. Can you tell me what's unique about this problem? What do you see? What do you see between the 2 binomial? Just tell me what you see. It's not no trick question here. Just tell me what you really just see. No trick question. Yeah, they same opposite side, right? We're gonna call it conjugate, but I'll show you that later. You got so let's do the FOIL method first. So 7 times 7. Again, I'll do slow. 7 times root 10. And then negative root 10 times 7. It's the same thing as 7 times negative root 10. So negative, right? Negative, positive become negative. So 7 times root 10. And then root 10, negative root 10 times positive root 10. So negative root 10 times positive root 10. 7 times 7 is 49. Negative root 10 times negative root 10 is, yeah, which is 10. Negative 10, very good. And what about the 2 here? They cancel out, right? They're the same. They're the same term, but the coefficient also same but opposite, so they cancel out. Kind of like think of it 7x minus 7x, right? So cancel. So 0. And then combine like term. So 49 minus 10, which is, yeah, 39. So that's one way. That's the FOIL way that you always know, always work. Now, another way, if you see something like that, they all the same. The only thing different is the sign between the numbers. Do you think of a formula that you've seen it before? Can someone tell me a formula you've seen before? Difference, yeah. Difference of,
Squares.
yeah, square. I have a minus b, or a plus b, times a plus b is equal to a squared minus b squared. A is just a is 7, root 10 is b. So for this one, another way I can use this is what? I have, let me rewrite it. I have 7 minus root 10 times 7 plus root 10. That's my a And this is my b. So can I rewrite it as what? 7 square, is that okay? Maybe you may write 7 in black. Minus, what is b squared? What's b? Root 10, right, root 10. 7 squared is 49. What square root of 10 squared? 10, right? The square and then the square root. Remember, the square root and the square, they are inverse of each other, right? So they cancel. So 10, 39. Whichever way you like. On the exam, whichever way you like. FOIL always work. Doesn't matter. You have different numbers, same number. But if you have the same number, you can see that the difference is square. Okay, the remark here is this thing called the conjugate. So this right here, they call the conjugate. What conjugate mean? It means everything the same except for the side in the middle. I hope I write right. Conjugate is spelled like that. Conjugate. So when the sides, let me look at my note here so I can. So when the side between two terms are changing, we call it conjugate. Excuse me. So conjugate is say a. So basically this is conjugate. H flow. So let me ask you a question. X plus y. What is the conjugate x plus y? According to the definition. Yeah, x minus y. What about 3a plus 4b? 3a minus 4b. What's the conjugate of 3a minus 4b? Mhm. Yeah. I don't know, is it there's an R between next to U? I don't remember. So 3a, yeah, plus 4y. So I say 4b, but I write y, sorry. So okay, so sample. So for example, sample here, example. It doesn't have to do with the conjugate, but let's do this one real quick so you can do your exam. This one, can I rewrite it at root 2 plus root 3 times root 2 plus root 3? Is that okay? Yeah. No. This square. A square minus b square, but here you have a plus b, so all of that square, so they're different things. Sorry, it's conjugate is done. Conjugate is done. No more conjugate. No more conjugate. That's just a remark. That's a remark for above. Let's do some more example that you might see on the exam. So here you have to use FOIL. What's root 2 times root 2? You tell me quick. Root 4, which is 2. What root 2 times root 3? Root 2 times root 3, root 6, right? And root 3 times root 2? Root 6 again. Root 3 times root 2 is root 6 again. And root 3 times root 3? Which is 3, right? 3. Okay. Combine like term, 2 times plus 3 is 5. What root 6 plus root 6? That's your hint. 2 root 6, right? If you don't see any number in front of the root, that's imply 1, right? So 2 root 6. when you're done. I want you to do number 2 at home. Okay, please practice at home. I'll give the solution after we're done here. That's it, we're done. Yay. Next Monday we have exam. So just give me a few more seconds. How do I stop sharing screen? Syllabus. When, your exam 2 is next Monday, and it has to be in person. Okay, it's include everything after exam 1, so 7.1 all the way to 8.4. All right, I'll get today I'm gonna try to get a practice exam for you. Same thing as before. Your exam very similar to practice and similar to the homework. I pick out a problem from the homework actually. Right, so do homework and then do the practice exam. You'll be fine. Okay. All right. Anything else? Right. Have a good weekend. Study hard, but spend some time for yourself. And I'll see you next Monday. Bye, Haya. Bye, Jacob. Thank you. Yeah. See ya. Take care. You too.
Bye.
Bye, Haya. Congratulations. Have fun.